Now we'll see a very different and new concept which is called latching. Now what does latching mean? It means when we press a button, like we have done in the first program, what we had an input x0 and we have an output y0. Now when I press x0, this y0 gets on. When I release this x0, this y0 gets off. But now what we want, when we press x0, this should get on, and when I release it, it should remain on. How to do that? How to make this possible? Because when you are cutting off the input, how it will remain on? So for that, we'll add an auxiliary contact. We'll add an auxiliary contact of y0 in the parallel of x0. Now these auxiliary contacts are the contacts of NO and NC of a coil. So what we have to do is we have to take y0 in the parallel of x0, and then we have to connect it in the parallel by pressing F9. So now let's compile it and let's see what happens. Now the program has been transferred. Now what happened when I press X0, this will get on, and due to this coil, this contact will get on. Now this is basically a principle of a relay, how a relay actuates its NO and NC contact. So this is an NO contact of this coil Y0. So when I press X0, this Y0 gets on, and when I release X0, we can see this Y0 remains on by its own auxiliary contact. So our question was to use X4, which is a push button, to perform this experiment. I have used X4. Now X4 is a push button, which I'll push it like you can see in the trainer. When I press it, Y0 remains on. When I release it, Y0 remains on because it has latched itself using its auxiliary contact. The next situation was I have to press X5 to unlatch it. It means to switch it off, I have to use a button X5. Now how this can be switched off? If you break this contact, now this is getting supply from here and from this Y0. If you break the contact between that, this will remain, this will get off. When it will get off, it will switch off its own contact Y0. So we have to add X5 here, and that too in NC. Instead of NO, now I'll use NC because NC are normally used to switch off the circuits. So I'll take X5 here. Now let's transfer this program. Now you can see X5 is already on because it is NC, normally closed. My X5 is internally off in a PLC, and externally I'm not pressing X5 presently, but its contacts NC is on. So when I press X5, this will get open because as I told you earlier, all these internal X0 to X7 are internal relays. So if my relay is off, this NC will be closed, this contact will be closed because it is NC, and this contact will get open when I press X5. Because what happens in a relay? In a relay, you have NO and NC contacts, and when you turn on the relay, NO contacts get closed. As we know, when we press X4, it gets closed, and NC contacts gets open. So it works in opposite to X4. They both work opposite to each other. So what happens when I press X4? Thus outputs get latched because this contact is already closed. It just acts like a wire. And when I press X1, this will get open and it will unlatch the X0 like this. So we just have to press it once and you can have the latching and unlatching operation. This is widely used in the industry, the latching of motors, contactors, solenoid valves. This is internally how it is done. Again, my wiring is same. I'm just changing the program. I'm using internal relays, internal contacts to latch and unlatch the circuits. Otherwise, if we are using this, if you have to perform this without using PLC, you have to use a relay, and you have to use its NO and NC contacts. So to avoid that, we have avoid a relay, and we are using the same principle inside a PLC. So that's how it works.